Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve question number 52 and 64 for of the GATE 2022 statistics paper. The problem 52, let us first consider. This problem says that there is a multiple regression model, say y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon, where epsilon is normally distributed with mean 0 and variance sigma square, and beta naught, beta 2, beta 3 are unknown parameters. So we have 52 observations of these variables, and which yield sum of squares due to regression is 18.6 and total sum of squares is 79.23. So we have to test the null hypothesis h naught for beta I equal to 0 for all I against the alternative that h1 is not h naught, that is beta I not equal to 0 for some I equal to 1 to 3. So to test we have to find the value of the test statistics. That is what we need to do here based on one-way ANOVA. So given the linear regression analysis model, y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon, where epsilon I is normal 0 sigma square and sigma square greater than 0 for I equal to 1 to 52. So we have sum of squares due to regression, which is SSR equal to 18.6, and the total sum of squares is 79.23. So we know that the total sum of squares consists of sum of squares due to regression plus sum of squares due to error. So here the sum of squares due to error will be SSTO minus SSR, which is 60.63. So you can prove this relation. You can try yourself. Okay. So this is basically sum of squares due to sum of squares due to total error. That is total sum of squares is basically sum yi minus y bar whole square for I equal to 1 to n, where n is the number of observations. So we have to break it in two parts. That is I equal to 1 to n yi minus yi hat whole square, which is SSRE. That is this is the actual value. This is the predicted value. So we got to get the difference and sum of squares. Take the sum of squares. So this is basically sum of squares due to error. Plus another term is yi hat minus y bar. So this is the sum of squares due to regression, SSR. So this total sum of square is consist of two parts. Okay. So similarly, the degrees of freedom will be, the SSR will be p minus 1 equal to 3. Here p is 4. Since we have total number of variables is p equal to 3. So we have total degrees of freedom will be p minus 1 equal to 3. P basically means the number of unknown constants, that is number of parameters in the model. So here p is 4 and p minus 1 equal to 3, which is the degrees of freedom of SSR, sum of squares due to regression. Similarly, sum of squares due to error is n minus p, that is 48. You can get it by the ANOVA table. Also, SSTO equal to SSR plus SSE. Also, we have SSE by sigma square follows chi square n minus p, and SSR by sigma square follows chi square p minus 1 independently. So we have, if we sum this, it will get chi square n minus 1, which is the total degrees of freedom. So we can justify also by this, the degrees of freedom. So based on one-way ANOVA, to test the testing problem given here, we can find the test statistic is basically SSR by p minus 1, that is the degrees of freedom, and SSE by its degrees of freedom, which we tell here. So this basically follows chi square n minus p and chi square p minus 1 independently. So their ratio will follow F distribution. So we find the value here, and the value is 18.6 by 3 and 60.60 by 48, which is 4.9. So 4.909. So the required value of test statistics is 4.909 up to 3 places of decimal. So here the motive of the problem is to find the value of F statistic required to solve a testing problem in the linear regression setup under an one-way analysis of variance. Okay. Next, consider problem number 64, which says that x and y were two random variables where x is uniformly distributed over 0, 4, and the conditional distribution of y given x equal to small x is uniformly distributed over 0 to x square by 4. So we have to find the expression of y square. To find, let us consider that we have x follows uniform 0 4 and y given x follows uniform 0 x square by 4. So basically the PDF of the conditional distribution of y given x equal to x is 4 by x square, where y lies between 0 to x square by 4 and 0 otherwise. Okay, please check if you are not getting it. Okay, this is the conditional PDF. So we have to first find the expectation. To find expectation of y square, we use this formula. We have expectation of y equal to expectation of y given x, the conditional distribution formula using. So similarly, using this expectation of y square is basically double expectation of y square given x. So we first find this internal part, that is expectation of y square given x, which is basically get in by integrating the PDF of conditional distribution of y given x, which yields the value x square by 48. So we have expectation of y square given x equal to x square by 48. Okay, so now we have to find the double expectation. So this becomes simply expectation of x to the power 4 by 48, which we have the integration 0 to 4 x to the power 4 by 4 dx, because x follows uniform distribution over 0 4. So the PDF will be 1 by 4 into, for x lies between 0 to 4. This will be the PDF of x. We integrate PDF of x. Okay, so integrate and get the value 16 by 15, that is 1.067. So the required value of y square is 1.067 after 3 places of decimal. So thus, in this, the motive of this problem is to find the expectation using the double expectation formula. Okay, so that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.